Did China just stumble onto proof that Mars was alive far more recently than anyone ever imagined? For decades, scientists have searched the red planet for signs of water, oceans, and maybe even life. NASA rovers have dominated the headlines, but quietly, another space program stepped onto the Martian stage. Against all odds, China's very first rover not only landed successfully, it began uncovering clues that suggest Mars's story might be stranger, wetter, and more alive than we ever dared to think. And what Zhurong, the little robot explorer found buried under the Martian sands, may change how we see our neighboring planet forever. When China announced it was sending a rover to Mars, most experts didn't think it would work. After all, this was a mission where even the biggest players had failed. The Soviet Union's early attempts ended in silence. Britain's Beagle 2 never powered on, and even NASA, the leader in planetary exploration, lost its fair share of landers before finding success. So when China revealed its plan in 2020, many thought it was far too ambitious. They had landed on the moon before, yes, but Mars is a different beast entirely. Thin atmosphere, violent dust storms, and a history of swallowing spacecraft whole. The rover itself, named Zhurong, wasn't flashy, about medium-sized, solar-powered, and designed with a style similar to NASA's older Spirit and Opportunity vehicles. In short, a first attempt that looked modest compared to America's nuclear-powered SUV-sized machines. But here's where things get interesting. Against the odds, Zhurong made it. It touched down safely on the flat plains of Utopia Planitia, rolling onto the Martian surface as the very first robot from China to do so. That alone was history. And yet, what Zhurong would uncover beneath those sands turned out to be far more than just a technological milestone. It hinted at a story Mars had been hiding for billions of years. Long before China ever dreamed of sending a rover, another mission may have come dangerously close to answering the question: is there life on Mars? Back in the 1970s, NASA's Viking landers ran the very first biology experiments on Martian soil. The idea was simple but groundbreaking: scoop up some dirt, feed it water mixed with nutrients, and watch for signs of metabolism. To everyone's shock, the soil responded. It released carbon dioxide, exactly what you'd expect if tiny microbes were eating and breathing inside the sample. For a brief moment, it looked like the experiment had confirmed alien life. But then came the twist. When scientists added more nutrient-rich water, expecting an even stronger reaction, the soil went quiet. The gases faded. And just like that, NASA declared the result a false alarm. But not everyone agreed. For decades, some researchers have argued that maybe we really did find Martian life and accidentally killed it. Imagine a microbe that had adapted to survive in the driest conditions imaginable, clinging to existence in a place harsher than Earth's worst deserts. When NASA suddenly drowned it in liquid water, it might have been too much. In trying to test for life, we may have smothered it instead. It's a chilling thought, and it set the stage for Zhurong's arrival in Utopia Planitia, the very same region where Viking once landed, a place filled with rumors, controversy, and the possibility that Mars's biggest secret has been waiting all along, buried just beneath the dust. Once Zhurong settled into Utopia Planitia, the real work began. On board were 3 key instruments: cameras to capture the Martian landscape, a laser to blast rocks open and study their insides, and most importantly, a ground-penetrating radar capable of seeing far below the dusty surface. And that radar started picking up something strange: layer upon layer of buried structures, not random, but organized, tilted, and stacked, almost like pages in a history book. Over a mile of terrain, Zhurong detected 76 distinct layers sitting 10 to 35 meters underground. What made it truly shocking was the shape of those layers. They weren't flat. Instead, they sloped in one direction, northward, exactly what you'd expect to see in a coastal environment here on Earth. In other words, Zhurong was sitting on top of what looked like an ancient shoreline. For decades, scientists suspected Mars once held oceans, but this was something more concrete: physical evidence carved into the very ground. And it wasn't just a snapshot in time. The depth and thickness of those layers suggested that water had been flowing, pooling, and reshaping the land for tens of millions of years. Mars, it seemed, wasn't just wet in the distant past. It may have been active, dynamic, and full of change long enough, perhaps, to create the conditions for life itself. But that was only the beginning, because as Zhurong rolled forward, it uncovered signs that Mars' oceans may have lasted far longer and returned far later than we ever believed. For years, scientists believed Mars dried up over 3 billion years ago. The story seemed simple. Oceans formed, water vanished, and the planet turned into the cold desert we see today. But Zhurong's discoveries began to unravel that timeline. Deep beneath the surface, the rover's radar revealed evidence of a massive flood that swept through around 3 billion years ago. That was already surprising enough, but higher up in the soil, the instruments found signs of yet another flood. This one didn't happen billions of years ago. It happened just 1.6 billion years ago. That changed everything, because while Mars was still experiencing floods, Earth's oceans were already thriving with microbial life. At the very same time our own planet was bursting with biological activity, Mars still had water running across its surface. It meant Mars wasn't just wet in the ancient past. It stayed wet far longer than anyone had imagined. And if water lingered for that much extra time, then the window for life to take hold on the red planet may have been far wider than scientists ever believed. But Zhurong's journey didn't stop with buried layers. As it climbed small dunes and crossed the Martian desert, the rover stumbled across something even stranger, a discovery that hinted water might have shaped the planet not just billions, but hundreds of thousands of years ago. As Zhurong moved deeper into the Martian desert, it climbed a series of small dunes. Nothing dramatic, just low, sandy ridges stretching about 30 meters long and barely a meter high. But what it found at the top was anything but ordinary. The dunes weren't just piles of dust. Their surfaces were sealed under a hard, crackling, salty crust that ran several centimeters deep, almost like a thin layer of cement. And here's the problem. On Mars, with its constant dust storms, a crust like that shouldn't even exist. The winds would have stripped it away long before it had time to form. So how did it get there? The most likely explanation is stunning. Liquid water once soaked into those dunes, evaporated, and left the salts behind, hardening the sand into a crust. In other words, Zhurong had stumbled upon evidence of water activity, not billions of years ago, but far more recent. How recent? Chinese studies suggest it may have happened as little as 400,000 years ago. Think about that. While early humans and Neanderthals were roaming the Earth, snowstorms may have been falling on Mars. Water vapor drifting down from the polar ice caps, condensing into snow and melting just enough to hydrate the Martian soil. The red planet wasn't just a relic of ancient oceans. It was still active in a way no one had truly expected. And if Mars could host snow and liquid water in its recent past, then the planet's climate might be far more complex and more alive than the dry, dead world we've been taught to imagine. But the question is, what drives these sudden shifts in Mars' climate? The answer lies in the strange rhythm of the planet itself. So how could Mars, a frozen desert with an atmosphere barely thick enough to breathe through, have snow and liquid water only a few 100,000 years ago? The answer might come from the way the planet moves through space. Just like Earth, Mars doesn't orbit the sun in a perfect, unchanging pattern. Its path shifts and wobbles over time, creating what scientists call Milankovitch cycles. On Earth, these cycles drive the rise and fall of ice ages. On Mars, they may do something even stranger. First, the planet's orbit slowly changes shape, sometimes nearly circular, sometimes stretched into a wider oval. That alone can alter how much sunlight different regions receive. Add to that a shifting axial tilt, which swings between 22 and 25 degrees over tens of thousands of years. More tilt means harsher seasons, hotter summers, colder winters. Less tilt, and the climate evens out. Finally, Mars has a subtle wobble in its spin, which changes the timing of its seasons over tens of thousands of years. Put it all together, and you get a planet where the poles can warm, ice can vaporize, and snow can fall in places that seem impossible today. Every so often, Mars may slip into a cycle that transforms its climate, melting ice, releasing vapor, and even flooding parts of the planet. It's a rhythm written into the orbit of Mars itself, a cosmic metronome that might bring back water over and over across millions of years. And if water kept returning, then life may have had more than one chance to emerge. Which brings us to the most provocative idea of all. Maybe Martian microbes were out there, adapting, surviving, and evolving in ways we never expected. If Mars really did go through cycles of melting and freezing, with oceans and floods returning again and again, then there's one question we can't ignore. What if something learned to survive through all of it? Imagine a microbe perfectly adapted to the Martian rhythm, hydrating when water appeared, drying out when it vanished, and waiting patiently for the next cycle. A life form not fragile like those on Earth, but hardened by millions of years of extreme droughts and violent floods. Some scientists think this idea isn't so far-fetched. After all, we know microbes on Earth can survive in boiling acid, radioactive waste, and even inside Antarctic ice for thousands of years. If Earth's tiny life forms can pull off those miracles, why couldn't Mars have its own survivors? Which brings us back to a haunting possibility. What if NASA's Viking experiment in the 1970s did find them and drowned them before we even realized what they were? What if Zhurong's radar wasn't just detecting old coastlines, but the layered footprints of an ecosystem that once thrived under Martian skies? The truth is, we don't know. And maybe that's what makes Mars so compelling. It's a planet that seems dead on the surface, but keeps leaving behind whispers of something more. Something that might still be out there, hidden just beneath the dust, waiting for the right season to wake up again. If Mars really did go through cycles of melting and freezing, with oceans and floods returning again and again, then there's one question we can't ignore. What if something learned to survive through all of it? Imagine a microbe perfectly adapted to the Martian rhythm, hydrating when water appeared, drying out when it vanished, and waiting patiently for the next cycle. A life form not fragile like those on Earth, but hardened by millions of years of extreme droughts and violent floods. Some scientists think this idea isn't so far-fetched. After all, we know microbes on Earth can survive in boiling acid, radioactive waste, and even inside Antarctic ice for thousands of years. If Earth's tiny life forms can pull off those miracles, why couldn't Mars have its own survivors? Which brings us back to a haunting possibility. What if NASA's Viking experiment in the 1970s did find them and drowned them before we even realized what they were? What if Zhurong's radar wasn't just detecting old coastlines, but the layered footprints of an ecosystem that once thrived under Martian skies? The truth is, we don't know. And maybe that's what makes Mars so compelling. It's a planet that seems dead on the surface, but keeps leaving behind whispers of something more. Something that might still be out there, hidden just beneath the dust, waiting for the right season to wake up again.